Hello, good afternoon, friends. Today, the last point of the oxidation chapter is the selective oxidation at functional group, that is cleavage of glycol, diol, by using sodium periodate or by using the lead tetraacetate. So, let's see first with the sodium periodate. So, R OH R dash. So this glycol, that is diol, on oxidation by using sodium periodate, it gives RC double bond OH plus R dash C double bond OH plus NaIO3 plus H2O. So these two aldehydes means the cleavage of carbon-carbon bond take place at the diol, means the two carbon-carbon present here break down by using the sodium periodate. So let's see the mechanism of this reaction. Now in mechanism, the diol OH R dash attack on periodate O minus Na plus. The lone pair from the oxygen attack on the iodine, there is O minus, and O minus take the proton from this to form the lone pair of the oxygen is retained. So we directly show here as R O I O H. So this O minus take the proton from this OH. Now here is OH double bond O minus Na plus. Okay. Now again the another lone pair of oxygen attack on iodine, there is O minus, and this O minus take the proton. Again the lone pair of oxygen is retained. So that again the cyclic iodate ester is formed. I O double bond OH O minus Na plus. Okay, this become OH O minus Na plus and C double bond, I double bond O. Now again there is cleavage. This O minus goes to here. This break down the IO bond, formation of C double bond O, breaking of this bond, formation of C double bond O, and there is again a retention of lone pair. There is loss of OH minus. So there is formation of RC double bond O H plus R dash C double bond OH. So this bond forms R C double bond O. Here is H. Here is also R C double bond O. Here is also H. Aldehyde plus O minus. So I O H double bond O. There is OH minus. This OH minus, and there is Na plus. So this OH minus take the proton. There is O minus and this Na plus. It forms as NaIO3, NaIO3 and H2O. So this is the mechanism. By using sodium periodate, there is formation of the diol converted to two carbonyl groups. So let's see more example of this reaction. pH. Now trans stilbene by using osmium tetroxide and sodium periodate. So osmium tetroxide form the diol, and the diol get cleavage to form the aldehyde. So two molecules of benzaldehyde is formed during these reactions. Let's take another example. pH pH, try substituted olefin, alkane. Again the same reagent, sodium periodate and ruthenium tetraoxide. So ruthenium tetraoxides form the diol, and diol again cleavage by the sodium periodate to form the PHCH benzaldehyde plus PHC double bond O PH benzophenone, and the benzaldehyde is formed as the product. Okay, let's take more example of diol. Cyclic cyclohexane diol, OH, then NaIO4 sodium periodate undergo cleavage. Now here this bond undergo cleavage to form the 6 carbon diol, that is hexane diol. C double bond OH, 1 2 3 4 5 6. So this diol 1 2 3 4 5 6 hexane diol is formed. Okay, now let's see the oxidation by using periodic acids. So instead of sodium there is hydrogen, then it is the periodic acid, and this periodic acid, same mechanism to form the again aldehyde, by cleavage of diol, that is glycol. So let's see the another example. OH, NaIO4 sodium periodate. Now here is again cleavage of this bond take place to form the 1 2 3 4 member aldehyde, and plus 1 is formaldehyde plus NaIO3 and water. Okay, now let's see the another type of oxidizing agent, that is lead tetraacetate. So lead tetraacetate, again there is cleavage of diol or glycol to form the aldehydes, or there may be formation of ketone take place. So let's see the example. There is OH. So it is two cyclohexanol ring joined together, that is decaldiol, by using lead tetraacetate. This forms C double bond O C double bond O. So this type of the ketone is formed, that means cleavage of again this bond take place and to form the such type of product. Here we can show this product as, so this is the cleavage of this carbon-carbon bond of the diol and to form the carbonyl groups. Let's take another type of example. R1 OH, R2 OH, R3 and R4. So by using lead tetraacetate, again there is R1 C double bond O, R2 plus R3 C double bond O, R4. So this product is formed. So let's see the mechanism of these reactions. Mechanism: R1 R2 OH, R4 and R3. Now this OH attack on lead tetraacetate. So OAC thrice. Okay. So the lone pair attack on lead, there is loss of OAC. Acetate group is removed as it is a good leading group. So there is formation of R O Pb OAC thrice. Again there is OH R3 R4 and this R2 R1 remain as it is. Means again there is this acetate ion takes the proton, that means it lost acetic acid. So this O minus takes the proton, it lost as an acetic acid. Again this lone pair of another OH group attack on lead, there is again loss of one OAC group, and that OAC group takes the proton, means minus ACOH, another acetic acid molecule is removed. Now cyclic intermediate is formed, OPB OAC OAC, again O R4 R3 R2. Now there is no cleavage. Now this carbon-carbon bond breakdown. Now this bond is shifting here. Cleavage of this bond shifting here to form the C double bond O, and there is loss of Pb OAC twice and R1 C double bond O R2 plus R3 C double bond O R4. So these two carbonyl compounds is formed from the diol. The diol get converted to carbonyl compounds by using the lead tetraacetate. So let's take another example. Now the dicarboxylic acids COOH. So dicarboxylic acid present on adjacent carbon. Now by using the lead tetraacetate, this dicarboxylic acid get converted to alkene. So let's see here, Pb OAC and OAC thrice. Now again the C double bond O, carboxylic acid and OH, the lone pair attack on OAC is lost. This OAC takes the proton, it becomes OPB OAC twice or OAC. There is 3 OAC. Again C double bond O. There is C double bond O OH. Now there is a decarboxylation. This dicarboxylation takes place during these reactions. So this OH bond sit here to form the C double bond O. Now this C bond sitting here to form the double bond. Now this bond sitting here, loss of CO2. Here is also one CO2 and one OAC is removed, and that OAC takes the proton. That is formation of acetic acid by taking the proton. So we get C double bond C alkene plus Pb OAC twice plus 2 CO2 and plus ACOH. So this OAC takes the proton, it forms the acetic acids. So from the dicarboxylic, this dicarboxylic acid, this dicarboxylation takes place and to form the alkene as a product. Okay, let's see more example of the oxidation. Another type of example, RCH C double bond O R. Okay. Now on enolization, this proton shifting on oxygen to form the enol, R C double bond C OH R. Okay. Now this enol treated with lead tetraacetate PbOAC OAC thrice. Okay. Now this lone pair attack on here one OAC, one acetyl group is removed, that acetyl takes the proton. Again the lone pair of oxygen is retained. So R C R double bond C O Pb OAC twice and one OAC O C double bond O CH3. We write here as, and here is R. Now the oxygen lone pair attack on this carbon, then shifting of this bond here to form the C double bond O, and there is breaking of PbO bond. Now see here RCO C double bond plus CH3 PbOAC twice. Okay, and here is RC double bond O, again formation of carbonyl compound written here at least. Now there is breaking of hydroxylation, hydrolysis. So OH2 attack on here, it gives RC RO, lone pair is written COH CH3 PbOAC twice. So C double bond O R. Now this OH bond shifting here, breaking of PbOAC take place, and to form the RCOAC C double bond O R R. So there is alpha acetylation take place at the carbonyl group if there is proton is present by using lead tetraacetate. Okay, so this is the cleavage of glycols by using the lead tetraacetate and by using the sodium periodate. Thank you. We will start next topic, that is a reduction, in new video. Thank you.